Hello everyone, welcome to our channel. So in this series we are taking one more question of previous year control system questions asked in the GATE exam. So all right, so hope this series will be helpful for you, all of you. So all right, this question I am stating here. The consider negative unity feedback system with a forward path transfer function. They given s square plus s plus 1 by s cube plus 2s square plus 2s plus k. Alright, so actually they given the forward transfer function. Generally we consider the gs, okay, where k is a positive real number. It means k greater than 0. The value of k for which the system will have some of the its poles on the imaginary axis. Okay, like they asking for what value of k system poles will be. System poles will be on the imaginary axis. All right, somewhere you will get it. So for this, what is the k value? Okay, so how to solve this type of question? Like as we know, whenever they given like polynomial, so whenever we talk about the um, location of poles, and whether it is a right hand side of the S plane or j omega axis, whether it is a right hand side of the S plane or whether it is a left of the S plane or in a j omega axis. So for this we need to apply the Routh-Hurwitz Cartesian. Okay, so all right. So here as we know, Routh-Hurwitz table can be used to compute the number of roots of characteristic polynomial. What is a characteristic polynomial? Here they are giving the negative feedback system, negative unity feedback system. I already told in our previous video, in control system generally we refer the use the negative feedback. All right, because then only control system would be stable. So here, like our unity feedback system, this our forward transfer function, okay, and they given here unity feedback system HS should be 1, okay. This is our output, this is our input. All right, so if you find out the closed loop transfer function for this, we get gs by 1 plus gs into hs. So here I am just referencing here like plus minus, plus for negative feedback and negative for the like gs by minus gs into hs. This for the positive feedback. Sometimes they in question they can ask actually. Okay, all right. But we should remember that in case of a stable system, our feedback should be in negative or in nature. Okay, so this is a we have to apply here. So what is the characteristic equation for this? This denominator polynomial is a is called the characteristic equation here. Yeah, characteristic polynomial. Okay, so here characteristic polynomial is 1 plus gs into hs. This is a characteristic polynomial. All right, and what is the characteristic equation? 1 plus gs into hs equal to 0. This is a characteristic equation. This is a characteristic polynomial. All right. Okay. So we need to find out whether a given system, whether poles in a right hand side of the S plane or left-hand of the self-explain. Okay, so here our they asking that when the system uh, has the poles on the imaginary axis, that time what is the gain value, I mean k value. All right, so as we know, in case of pole pair on the imaginary axis would give the a row of zeros in the Routh-Hurwitz table. So once imaginary axis pole will be exist, that time in Routh-Hurwitz be row of zeros will be form actually. Okay, so occurrence of row, as we know, this is one case. Okay, occurrence of row of zero in Routh-Hurwitz, there are three cases. One case either in j omega axis. Okay, pole pair there, this thing we will see today. And second case, we will see the symmetricity of object in the origin with respect to the origin, like that you can see. So this type of case we already discussed in I think 2018 GATE exam. In you can I will pin this link, okay, of this video. You can refer it. It's very helpful. Okay, and last one is a symmetry is also observed. Okay, so here you can see in j omega x also symmetry observed. Okay, with respect to the origin. For this purpose, that reason our Routh-Hurwitz table, the row of zero exists. Okay, so hope you understood. All right, so let me first form the Cartesian equation. Okay, so here Cartesian equation is 1 plus gs into hs equal to 0. All right, so Routh-Hurwitz table with the in order to solve the poles, yeah, poles, yeah, roots of the polynomial. Okay, without solving we can tell how many number of poles lie in the right of the S-plane and imaginary axis, yeah, left of the S-plane. Okay, so that's a significance of Routh-Hurwitz table, Routh-Hurwitz criterion. All right, so here 1 plus gs they given the in question a square plus s square plus s plus 1 by sq s square plus s plus 1 by sq plus 2s square plus s plus k. Okay, and hs is equal to 1 is 0. Let me see that this is 2s. Okay, this is a 2s. All right, so here otherwise we can write just solve it, then you get the 2s plus 2s plus k equal to 0. Hope you understood. All right, then simplify the 2s square, this is same term. Okay, so 2s square plus s square, this is a 3s square. All right, 2s plus s, this is 3s, and finally this is a constant term k plus 1. So first we need to write the polynomial equation at a descending order. Okay, so like we already sq s square s power 1 like that is already there. Then we need to form the Routh-Hurwitz criterion table. So s square sq s square s power 1 and finally the constant term s power 0. Then s q is alternate coefficient 1, s square coefficient is 3. Then again go this side, then 3s square and not 3, this is s na 3, then again fill it like that, then finally k plus 1. All right, basically alternatively we can fill this term. coefficient. All right. Then multiply this, then divide by multiply this 3 into 3 minus k plus 1 into 1 divided by 3. Okay. Okay na? K plus 1 into 1. So you will get finally 9 minus k plus minus 1 will get 8 minus k by 3, and this is finally 0. Okay. Then if you again multiply, then 8 minus k by 3 into k plus 1 minus 0 into 3 divided by 8 minus k by 3. Alright. So 0, 0, 3 can, this is 0. So this is again cancel out, get again constant k plus 1. So for imaginary axis pole is exists, that time when 0 of row, no, row of 0 would be exist here. So this will be exist when the k is equal to 8. Alright. Okay na? When k is equal to 8, then this 0 will be exist. So then just above this row is called the algebraic equation. So for the algebraic equation here, this is a 3x square plus k plus 1. This is our algebraic equation. Okay, if you solve it, you will get the poles existence on the imaginary axis. So solve it to k plus 1 by 3. Alright. Then just substitute k value. So here k value if you substitute, then you get 9 by 3, you will get the minus 3. Okay. Okay na? Then finally, if we are to find out the root, there are two roots will be there. So plus minus root 3j. Purely imaginary axis. Okay. So here our question was poles lie on the imaginary axis. That time k value will be 8. Okay. Alright. So option is B is correct option. Okay. So be careful. Sometimes when we solve it, that time we generally option in A. Sometimes people they mark actually, because sometimes the k plus 1 here forming here, they forget the subtracting the 1 value. Alright. So this is very important. And one more thing actually, like this question was very simple. They can also ask like for what value of k range they also can find out maximum value k range for which system would is stable. So here as we know k greater than, here you can see this should be k plus 1 greater than 0. So k greater than minus 1. Okay. And k less than 8, maximum value 8. So you can see k range will be 8 to minus 1. So 0 will also there. Okay. But since they saying here positive real number, so this we can this value will not be there. So we can say 0. This is range. Okay. So like that we can also extend this question. All right. So here they given directly like poles on the imaginary axis, and they can also ask like maximum value or maximum range of k but system would is stable. After this, if you increase the k, our poles will be go at the right end of the spline, like this. Typically we are saying that this is like root locus and going this side, and k here is a 8. Okay, after this our pole exists in the right of the spline, so system goes unstable. Okay, so till k is equal to 8, that time the k less than 8. Okay, 0 and k less than 8, then system would is stable. Okay, so generally, stability related questions they generally ask. Okay, frequently asked. Okay, and like Routh using the Routh-Hurwitz table. Here in Routh-Hurwitz table, you need not to solve, exactly roots, yeah, poles, where location, but still we can find out, we can tell how many number of poles and zero lie on the left and right of the spline, j mega axis. Okay, but this is special case, like when we exist the row of zeros at the Routh-Hurwitz table. There are three possibility. Okay, either pole exist on the j mega axis only, yeah, symmetricity involved. Okay, with respect to the origin we can say, yeah. Okay, so like right up the spline, this is j mega axis, and this is our sigma mean real axis, symmetry observed. Okay na. So like this here, for example, minus plus minus 1 plus 2j. This is a minus plus minus 2j. Similarly here plus 1 plus 2j. Okay, plus 1 minus 2j. Okay, so like that we should understand the special case, of Routh-Hurwitz table. Okay, so this question are very simple. Okay, so that's all for this video. Okay, and I will also pin one more video, like link of this video, and this question actually, like this case I already discussed. This type of case, they ask in the GATE exam, I think 2018. I will pin this link of this video. You can also watch this video, very helpful to understand, understand the Routh-Hurwitz in more details. Okay, so that's all for this video. Okay, if you any doubt, please do comments. Okay, thanks a lot.